Hello, I'm Lynn Bondurant, your host for our series, 25 Years of Progress. During this 13-part series, we see some of the highlights of NASA, the National Aeronautics and Space Administration, since its official founding on October 1, 1958. What is happening in other American science and medicine the year before NASA is born? Well, 1957 is the year the American Cancer Society reports a high correlation between cigarette smoking and lung cancer. And new element nobelium-102 is disclosed by the Argonne National Laboratory in Lamont, Illinois. Overseas, on October 4, 1957, the Soviet Union launches Sputnik 1, the first artificial satellite. The Soviets' launch is for the International Geophysical Year, or IGY. The geophysical year is 18 months, from July 1957 to December 1958. More than 70 nations and as many as 30,000 scientists cooperate to investigate the world and its environment. Sputnik 1 concerns Americans because of far-reaching military and technical implications of the launch. Less than a month after the first Sputnik, the Russians launch a second Sputnik, which weighs about half a ton and carries a dog as a passenger. The second Sputnik causes even more concern in America because of the large size of the satellite. During IGY, the United States plans to launch a Vanguard satellite, which weighs just a little over 3 pounds. The attempt to launch the Vanguard on December 6, 1957, ends in failure in a ball of flame and wreckage. T. Keith Glennon is the first administrator of NASA. He is asked why NASA was formed.
That's a fairly easy question to answer. Sputnik, on October 4th, 1957, as I recall it, the Russians launched a fairly heavy object into orbit, and that caught us really by surprise. The Vanguard project had gotten underway in 1955, as I recall it, part of the IGY program, International Geophysical Year program, but it wasn't anywhere near ready. They had, I think, scheduled some launches late that year, that is in 1958, but it wasn't clear that they were going to be able to fly them. There was another competitor which had really never been recognized, and that was the Army with their Jupiter, which together with some upper stage solid rockets developed by the Jet Propulsion Laboratory in California, finally was the vehicle which launched a satellite for the U.S. early in 1959.
And the satellite was called Explorer 1. Let's go back to after Sputnik's success and Vanguard's spectacular failure. when Major General John Medeiros and Dr. Wernher von Braun and their team at the Army Redstone Arsenal are given their long-sought chance, a go-ahead to launch an American satellite. They will use their flight-proven Jupiter-C rocket launcher. We are at Cape Canaveral in late January 1958 as the covered satellite is placed atop the Jupiter-C poised on pad 26 for firing. Explorer 1 is to be about 30 pounds in orbit. Severe winds aloft force a 2-day postponement. Then on January 31st, 1958, the United States answers the Soviet challenge in space. Explorer makes a major discovery, a radiation belt around the Earth. Dr. James Van Allen of the University of Iowa identifies the region. The discovery of the Van Allen belt is an important finding of the International Geophysical Year. During a satellite television program broadcast in 1978, Dr. Ernst Stuhlinger, Director of Science for Dr. Wernher von Braun, makes this statement about the launch of Explorer 1.
It was a gate that opened into a new land. We hoped at that time that we will make progress and achieve many more things in space beyond launching a small satellite. I want to be honest though and say that at that time we did even not think it possible that 20 years later there may have been 12 men walking on the moon and coming back to Earth in good shape. Many of the dreams which we had at that time were fulfilled, but many other dreams which many achievements were accomplished which we even did not dare to dream at that time. However, when we look forward now toward the next 20 years, I have the feeling that the best is yet to come.
The United States space effort before the launch of Explorer 1 is fragmented. Navy, Army, Air Force, National Science Academy, and NACA. President Eisenhower appoints James Killian to be science advisor just after the first Sputnik launch. Keith Glennon recollects the writing of the Space Act which forms NASA.
My recollection would be that Mr. Killian, who was the President's science advisor, had been appointed almost immediately following the launch of Sputnik, and PSAC, the President's Science Advisory Committee, and I suspect Mr. Lyndon Johnson on the Hill did a sort of a cooperative job in putting together the Space Act. They had as a model the Atomic Energy Act. And indeed, if you compare the two, you find a good deal of similarity in many of the clauses in the two acts.
I see. Well, what were the major implications of the Space Act?
They simply said that we were to pursue the development of activities in space for the benefit of all mankind. We were to do it as a civilian agency. We were to be responsive to the military in the sense that if we found in our developments some gadgets, some information that would be of value to the military, we were bound to give it to them. And that was really the thrust of this act. We were also told that we should pursue international activities. And this is, I think, an extension of this for the benefit of all mankind.
The Space Act is signed into law by President Eisenhower on July 29, 1958, and on October 1, 1958, NASA comes into being. Glennon recalls Eisenhower's feelings about space.
He was not a space cadet. He used to say, as you look over his shoulder and you say, you know, Keith, that moon's been there a long time. It's going to be there a great many eons yet. And we'll get there one day, but it isn't necessary we break our necks and break the budget to get there now.
Okay, what about congressional support at the time?
Congressional support was really very good. As a matter of fact, they were pushing us. I don't think in my 20 months there that I ever had a budget proposed to them that they didn't want to add something to. My stock answer was, I have studied this, we have presented you with a budget which is what we think we can usefully use. If we need any more, you may be certain I'll come right back to you. That seemed to satisfy them.
Before NASA is born, Keith Glennon is president of Case Institute of Technology and former commissioner of the Atomic Energy Commission. Then Eisenhower nominates him to be first NASA administrator in August 1958 with Dr. Hugh Dryden as deputy. And NASA is formed from the National Advisory Committee for Aeronautics. Glennon explains.
And we did inherit the National Advisory Committee for Aeronautics operation, NACA as it was then called, of which Lewis Laboratories was one. There were 4 or 5 such laboratories, 3 big ones, Ames, Langley, and Lewis, and one at Wallops Island in Virginia and one out in Edwards Air Force Base in California. But we had 8,000 well-trained, loyal, dedicated people in NACA, and they formed the base on which we erected NASA. So we were very well endowed.
NACA was formed in 1915 to supervise and direct the scientific study of the problems of flight with a view to their practical solution. NACA was required to direct and conduct research and experiments in aeronautics. The committee was responsible for many of the advances in U.S. aviation through 1958. Some space-type research is done in later years, but emphasis was on airplane research. Again, Glennon tells us what happened in NACA space research.
NACA had been doing development work largely at Langley, as I recall it, on the shape of a capsule that might be used in an up and down flight like actually Mercury started out to be, and finally into an orbit. The problems of trying to get adequately capable people in a variety of fields meant that we had to look other than in NACA, and it became apparent very early on that our real limitation was in the launch vehicle business, the booster rocket as we then called it. We really didn't have any. We had been using sounding rockets, small things that went up and accumulated information and telemetered it back to the ground, but we didn't have anything that really would lift very much with any degree of surety. So I guess it was probably in November, might have been late October of 1958, that I made a trip to Huntsville with Hugh Dryden, my deputy, and one of the very, very great men in this space program. His name cannot and will not ever be forgotten. We came back. It is clear that von Braun had a real strong team there, very capable. We did try to get that laboratory, or part of it. I didn't want the whole thing. They had work going on for the Army. The Pershing missile was in development at the time. And they had as their really scientific support the Jet Propulsion Laboratory managed by the Caltech out on the West Coast near Pasadena.
Dr. Glennon is successful in his effort to continue the job of building the new NASA organization. Officials transferred JPL, the Jet Propulsion Laboratory in Pasadena, to NASA, and the role of the California Institute of Technology as JPL manager continues. About a year later, officials transfer a large segment of the Army operation at Huntsville to NASA, and workers build it into the Marshall Space Flight Center. Only a week after NASA comes to life, Dr. Glennon approves the first U.S. manned spaceflight program, Project Mercury. Scientists developed the Mercury capsule shape through tests. Workers do wind tunnel tests of small and large-scale models, covering speeds from 0 to 18,000 miles per hour. Researchers fire small models of the capsule in a supersonic pre-flight ballistic gun range. The gun sends the 1-inch model down a 30-foot instrumented range of recording stations. The model goes 10,000 miles per hour. As the model speeds down the gun range barrel, photographs and shadowgraphs are taken. This shadowgraph shows airflow around the model. Workers develop boilerplate versions of the Mercury capsules for tests. This first test is a parachute drop test from an Air Force C-130. The capsule slides out of the plane's cargo door on a sled. The sled releases. A charge ejects a drogue parachute. Not only is NASA working on manned space travel, but from early on, scientists launched space science probes. Workers launched the Pioneer 1 probe toward the moon, about a week after NASA comes into being. A lunar TV scanner is aboard. Because of an error in burnout velocity, the probe does not reach the moon, but reaches an altitude of almost 71,000 miles, and the craft re-enters the Earth's atmosphere over the South Pacific on October 12, 1958. Glennon remembers that first Pioneer.
I guess we sort of broke our pick on some of those. I recall, those were the Pioneers, as I recall it. And I recall how overjoyed we were when we could talk to that little bit of a thing. It's about this big. So fashioned. 200,000 miles out in space and get the information back. It never did reach the moon or go into orbit around the moon. It failed and fell back to Earth. But at the same time, the Soviets could never talk to their birds more than 10,000 miles up. So we were beginning to get a little sense that we were doing things right, that we were getting better all the time, and that was indeed the objective of NASA in those days. Push the state of the art as hard as you could, but don't waste your muscle.
The United States tries 37 satellite launches by December 1959. Less than a third are successful. As a result, NASA begins to instill a new sense of rigid quality control to check and check and check again rocket components, wells, valves, pumps, materials, and so on. Over time, the quality control program works. In other areas of science and engineering, the first domestic jet airline service begins between New York and Miami on December 10, 1958. And in August 1959, plans to explore Antarctica in 1959 and 1960 are announced. In September 1959, Severo Ochoa and Arthur Kornberg received the Nobel Prize in Medicine for chemical heredity work. Meanwhile, the first 7 U.S. astronauts are chosen. Early in 1959, NASA selects a team of 7 engineer pilots for Project Mercury. M. Scott Carpenter, L. Gordon Cooper, John Glenn, Virgil Grissom, Walter Schirra, Alan Shepard, and Donald Slayton. The astronauts prepare for flight. After 2 hours, the astronaut comes out of a mold used to make a flight couch to fit his body shape. Early on, veteran test pilots look down on the role of the pilot in Project Mercury, but the Mercury pilot plays an active role. He controls the capsule's attitude and pitch, roll and yaw, as well as operating navigation and communication systems. In all Mercury flights, the pilot proves to be essential to the success of the mission. He operates all primary flight controls and initiates retro rockets to fire, beginning the descent to a landing. Whirling in a centrifuge cab, astronauts learn important lessons about how they react to the G-loads of emergency aborts. Meanwhile, workers test an escape system for the early Mercury capsule. The pilot must be able to escape from the Mercury launch site in case of an emergency. In this unmanned test, a 16-foot tower with a solid rocket sends the capsule safely away. During this test, a rhesus monkey is aboard. At more than 1,300 miles per hour, pressure sensing devices start the escape. Extensive Mercury program research and development continues. Workers launch a Big Joe Mercury test capsule nearly into orbit to test re-entry into the Earth's atmosphere. An Atlas booster carries the capsule to an altitude of 100 miles and nearly to orbital speed. From the recovery ships, the capsule appears as a flaming fireball as it streaks back into the atmosphere. Patrol aircraft fly to the impact area and pick up the capsule's recovery signals. 2 destroyers race to the area. The Navy ship Strong makes the pickup. The capsule survives its re-entry in excellent condition. Other areas of the space program are successful in 1959. By August, 10 of the 17 launches are good.
Please clear the launching area.
Also in August, NASA launches an Explorer 6, which functions well in all respects. Explorer 6 detects a large ring of electrical current circulating the Earth. During this first program of our 13-part series, we've seen how the launch of Sputnik in late 1957 encouraged the birth of NASA in October 1958. Early NASA projects continue through 1959. Lessons learned from early difficulties lead us to ever more successful performance. Next program, we pick up the NASA saga in 1960 when goals are still being set. I'm Lynn Bondurant.
Mercury capsule, no. All pre-start dial lights are correct. The ready light is on. Eject Mercury umbilical. Oil evacuate. Mercury umbilical clear. Mercury evacuate. Lights on. Roger, backup clock is started. That's looking good. Roger, Columbia on the roll. Columbia, Houston, you're go at 40. Roger, go at 40.